All right, welcome back. We're in Chapter 3, Section 2, using algebraic methods to solve systems of equations. In the previous video, we talked about the substitution method. In this video, we're going to talk about the elimination method. Sometimes it's called linear combinations or the add or subtract method. The main idea of this method, and actually the main idea of the substitution method too, is to get one equation with one variable. I have two equations with two variables. I got an x and a y, and I got two equations. That means I can solve it. But in order to solve it, I have to get down to just one equation with one variable. And I'm going to show the notes from last video real quick. That happened here because when I replaced in step one of the variables with the expression, then I had one equation with one variable. I just had to work it all out. Then I can use that number to substitute and get the other equation. Okay, so in the elimination method, we're still going to have step 3. That'll be the same, but I'm going to get down to one equation with one variable in a little bit of a different manner. All right, and here's how it's going to work. I want you to notice something about the way these are set up. These are going to be set up in what we call standard form. I'm going to write it up here. Standard form. If you hopefully you remember this from Algebra 1. Standard form for a linear equation is something times x plus something times y equals something. We talked about this when we were graphing boundary lines, and we used the intercept method. And don't concern yourself with why there's a capital A, capital B, capital C. It doesn't refer back, sorry, but it's the result of algebra being like a conglomeration of different ideas. So I've always seen it that way, but I've always questioned it. It's like, well, why don't we do something else? Could also be the fact that A and B, lowercase a and b, stand for the x-intercept and y-intercept. So maybe that's why we don't use the lowercase. All right. But anyway, I've got something times x plus something times y equals something. Same thing with that one. So both of these are already in standard form. That's what I want. And if you're wondering, and this will be in the next video, well, which method do I use? First of all, do what the directions say. The directions for this one say use elimination, so I'm going to use elimination no matter what. However, if you're just free to solve it, whatever method that you want, if it's already set up where it says y equals something, like in slope-intercept form, substitution is quick. If it's already set up where everything's in standard form, elimination is quick. So it saves yourself a step. That's why we need to like stop and think about how to solve things before we actually just dive right in. But like I said, since we're learning the skills, make sure you follow whatever the directions say. There's going to be problems that'll say solve by substitution and problems that'll say solve by elimination. And then you'll get your choice for the other ones. Okay, so let me show you how this works. What I'm going to do is I'm going to add the x's in both equations together. I'm going to add the y terms in both equations together, and I'm going to add the constant terms in both equations together. The reason why I can do this is because if this equals this, the addition property of equality says whatever I add to one side of an equation, I can add the same thing to the other side. Now most of the time, let me show you. Actually, I think I skipped it in the other ones. But most of the time, it's like this. If I do x subtract 7 equals 9, most of the times I just add a number to both sides. And then I get x equals 16. However, it doesn't have to be like a constant. As long as I'm adding something that's equal to something else, as long as I'm adding those to these two things are equal, as long as I'm adding what's equal to both sides, it'll be okay. So I can add everything here together. 2x plus 4x is going to be 6x. 3y subtract 3y is going to be 0 times y. And you're probably wondering why I wrote that. I'm going to tell you in a minute. 30 plus negative 4 is going to be, 34 plus negative 4 is going to be 30. Now, I'm usually never going to write this, but when I'm teaching, when I'm explaining, I like to show the hidden things. Okay, I don't want you to have the impression that, poof, it just disappeared. 3 plus negative 3 is 0. So 3y plus negative 3y is 0 times y, 0 y's. And of course, 0 times y equals 0. So this just gives me 6x equals 30. And if I divide both sides by 6, I get x equals 5. So like in the substitution video that I did just a moment ago, or that you saw just a moment ago, I have now reduced it down to one equation with one variable, and I can solve that equation for that variable. After that, I substitute into the equation. So, and one thing, remember how we did like a check? Well, you can actually substitute this into both of them, and if you get the same y value back, or if I solve for y, the same x value back, if I get the same thing, that means that I did it right. So I'm going to do 2x plus 3y equals 34. X equals 5. So 2 times 5 plus 3 times y equals 34. Let's do a little simplifying here. I'm going to save some space. I'm running out of room here. So I'm going to subtract 10 from both sides and get 3y equals 24. Because I subtracted 10, and I'm going to divide by 3. I'm going to get y equals 8. So it looks like my solution is xy. It's going to be 5, 8. Now, I can check my answer, y equals 8, my solution for y, by also trying the other one. So I'll do 4x subtract 3y equals negative 4. So my x is still 5. 4 times 5, subtract 3y equals negative 4. Do the multiplying. Now I'm going to subtract 20 from both sides. I get negative 3y equals negative 24, and divide by negative 3, I get y equals 8. Again, since I got y equals 8 here and y equals 8 here, I know I've got the correct answer. So that serves as my check, just plugging it into the other equation. So let's try this one. I have a problem with this one. Last time, 3y plus negative 3y, that was nice. It added up to 0y. I don't have that situation here. So I need to do something to make either the x's or the y's opposites of each other. And it doesn't matter which one you do. So I'm going to get the x's to be opposite of each other. So what I'm going to do is I'm going to multiply everything by 3. That'll give me 6x here. It'll also give me some other things over here, but I want 6x, 6 times x. And I'm going to multiply this one. I want this to be negative 6x, so I'm going to multiply by negative 2. One thing I do not want you to do not put parentheses around the whole thing. I've seen that from students coming in from other teachers. Don't do that. Put parentheses around both parts. You're not multiplying the entire equation. You're multiplying the left side by a number and multiplying the right side by a number. So I'm going to multiply this by 3. I'm going to multiply this by 3. And I'm sorry, I meant to put it right there. Sorry, it looked like an exponent. Excuse me. I'm going to multiply this by negative 2, and I'm going to multiply this by negative 2. Both sides. All right, so let's simplify. I get 6x plus 12y equals negative 30. I multiplied everything on the left and everything on the right by 3. I get negative 6x, negative 6y equals positive 6. Negative 3 times negative 2 is positive 6. Now when I add 6x subtract 6x is going to give me my 0 times x, just like I had 0 times y over here. So that's going to, I hate to say this, I hate to use like words that don't really describe things. People say cancels out. Well, what does that mean by cancels out? Or it drops out, okay? What's really happening is these two are opposites, and a number added to its opposite equals 0. Opposites, the actual word for it, are called additive inverses, and 0 is called the additive identity. So it's important that you know that as you study more math. Sometimes we just figure out, we try to go with, well, just give me the answer. But I'm really trying to come at it from the point of view of, I want you to understand what's really happening. So I do get 0 times x, and 0 times x equals 0. And 0 plus whatever this is going to be is just going to leave that. what is this going to be? I get 12y plus negative 6y. That's going to give me 6y. And negative 30 plus 6. Did I do everything right? Negative 30. I'm just checking my work because something weird's happening. Yeah, negative 6y, negative 6x, and positive 6. I think I'm okay. All right, so I should get negative 24. Sorry, it's you know how sometimes when you're like spelling a word and you look at it and you're like, even though you know you spelled it correctly, it just looks funny. Something just looked funny to me. I don't know if this is correct. I'll figure it out when I do the check. I'm going to divide both sides by 6 and I get y equals negative 4. All right, so that's what I think my first thing is going to be. Now, don't use your modified version. Go back to the original. 2x plus 4y equals negative 10. 2x plus 4 times negative 4 equals negative 10. 2x minus 16, and I'm going to add 16 to both sides. I get 2x equals 6. So x equals 3. So I think my solution is x equals 3, y equals negative 4. Let's try the other one to see if I get 3 again. So again, go back to the original. 3x plus 3y equals negative 3. 3x plus 3 times negative 4 equals negative 3. 3 times negative 4 is negative 12. And if I add 12 to both sides, I get 3x equals 9. Divide by 3, and I get x equals 3. So my solution, x equals 3, y equals negative 4. All right, I am going to pick up the pace a little bit so this video doesn't go too long. I thought putting 4 questions in a video was a bit much, but I tried to keep it organized that way. All right, for this problem, 7y and negative 7y, those are opposites, additive inverses of each other. The word opposite in real math is called additive inverses. And that word inverse is going to be really, really important as we study more math. Okay? Additive inverses add up to 0, which is the additive identity. It's called the additive identity because if you add 0 to anything, it doesn't change what you added it to. So 4x plus negative 12x is going to be negative 8x. 7y plus negative 7y is 0. And negative 25 plus 19 is 6. Negative 6. Ooh, this one's kind of nasty. I don't like this one. So I get negative 8x equals negative 6. Divide by negative 8, and I get x equals 3/4. Look out, we got a fraction. Maybe I did something wrong. But to be honest, sometimes you're going to get fractions. So it'll be okay. All right, let's put this back into the equation. So we got 4x plus 7y equals negative 25. This is 4 times 3/4 plus 7 times y equals negative 25. Now, 4 divided by 4 equals 1. By the way, those are called multiplicative inverses. Okay, 4 and 1/4, just like additive inverses. But anyway, I can do 4 times 3, which is 12, and 12 divided by 4 equals 3. The 4's like cancel out each other. And again, I hate that word cancel. All right? So I get 3 plus 7y equals negative 25. I'm going to subtract 3 from both sides. And I'm going to divide by 7. So I think I got y equals negative 4. Let's try it in the other equation and see if I got it. Negative 12x subtract 7y equals 19. Negative 12 times 3/4. I might need a new marker. This one's starting to get a little frayed. It's getting a little. It's not as, the point is not as sharp. So again, 12 divided by 4 is 3, and negative 3 times 3 is going to be negative 9. And if I add 9 to both sides, I get negative 7y equals 28. 19 plus 9 is 28. And that's nice because now I'm going to divide both sides by negative 7, and I get y equals negative 4 again. So even though I was a little panicked about getting a fraction, turns out that the fraction was okay. So x was 3/4 and y was negative 4. So the moral of the story, kids, don't panic if you get a fraction. Statistically speaking, you're more likely to get a fraction than a whole number anyway. The only reason you get whole numbers is because the authors of the books usually pick them that are nice. And that's something that is a little misleading. Okay, this one I don't have opposites or anything. I need to figure out some way to get things to drop out. I can get the x's to drop out, or I can get the y's to drop out. It doesn't matter. I usually like to go with the smaller numbers. So instead of 5 and 8, I'm going to go with the negative 3 and 5. So for this one, I'm going to multiply both sides by 5. And for this one, I'm going to multiply both sides by 3. That'll give negative 15y and positive 15y. So 5 times 5 is 25, 25x. 5 times negative 3 is negative 15y. And 5 times 42 is 210. Because it's 5 times 40 and 5 times 2. Excuse me. I'm going to multiply everything by 3. So 8 times 3 is 24. 5 times 3 is 15, positive 15. And 28 times 3 is going to be 84. Because it's 20 times 3, which is 60, and 8 times 4, which is 24. Okay, so now I'm going to add. 25 plus 24 is 49. 15, negative 15 plus 15 is 0. And 210 plus 84 is 294. All right, now you're probably thinking, all right, I got to get a calculator for this. No, you don't. You don't need a calculator for this. All right? Estimate and then think about it a little bit. This is close to 300. This is close to 50. 300 divided by 50 is 6. So 49, this is what I'm thinking as I'm doing my mental math. 49 is the same as 50 minus 1. So if I multiply by 6, that would be 300 minus 1 times 6, which is 294. So, and again, that's not good math showing, but that's just what's in my head. So it looks like if I divide both sides by 49, I'm going to get x equals 6. You can do that without a calculator, guys. All right, let's go back to the first one. 5x subtract 3y equals 42. X equals 6, so 5 times 6. That's 30. I'm going to subtract 30 from both sides. 42 to take away 30 is 12. I'm going to divide by negative 3, and I'm going to get negative 4. That has nothing to do with this over here, okay? Now let's use the other equation, see if I got it right. 8x plus 5y equals 28. So 8 times 6, which is going to be 48 in the next step. 48. Sorry, I was thinking ahead of me writing. I'm going to subtract 48 from both sides, and I get 5y equals negative 20. Divide by 5, and I get y equals negative 4. So my solution, xy, sorry, I'm starting to write the 6. This is what happens when I'm thinking faster than I'm writing. My x is 6, and my y is negative 4. Okay, so I'm hoping that you've seen substitution elimination before. It's going to be important as we learn more about algebra, that we're able to understand not just solving systems of equations, but how the process works. You've already seen substitution in places like where we do transformations of functions, where we substitute the x with x minus h, or 1 over b times x. The idea of elimination goes to the very core of what algebra really is. So there's more going on here than just tell me what the answer is. And that's really one of the important things I want to get through to everyone. It's not just about trying to find out what the answer is. Okay, we'll see you in the next video.